integration, area under a curve, type 3, above and below the x-axis. So we always have to be very careful with these questions here. For the very simple reason, if we're asked to get the area under the curve between the limits of a and b here, so if I highlight those 2 points in red, well, a and b, what happens to the graph is that it actually goes above the x-axis and below the x-axis. So if we were to just get the area between a and b by just simply integrating our function and subbing in, what we would end up with is the wrong answer. It wouldn't actually give us the area. And that's because if we notice where the function crosses the x-axis, it cuts the graph here where it's changing from above the x-axis to below the x-axis. So if I was to actually put in a third limit there, in other words, find where the graph cuts the x-axis by letting y equal 0, then if I actually get the area between a and c, I would find that I get a positive answer. And if I get the area between c and b, I get a negative answer. So of course, if you were to combine the positive and the negative answer, you'd end up subtracting areas, and really that wouldn't be a true representative of the area shaded here in blue and orange. So what we actually have to do is we must get the area above the x-axis and the area below the x-axis, and we add them. But of course, because below the x-axis is going to give us a negative area, we must actually get the absolute value of the area below the x-axis. So in other words, we're taking the absolute value. And this is because the area above the x-axis is positive, area below x-axis is negative. So let's look at a second example. So if we had a function like this, we can actually see there's multiple points where it's crossing the x-axis. And even if we're asked to get the area between the limits of a and b, well, what we actually find is that it'll cut the x-axis here. So let's call that c, cuts the x-axis here, d, cuts the x-axis here, e. So if we were to get between a and b, we'd have the negative bits cancelling out with the areas above the positive x-axis and would give us the wrong answer. So what we would actually need to do is break the shape into 1, 2, 3, 4 parts. We'd get the area between the limits of a and c. So c would be the upper limit, a would be the lower limit. We would then get the area between c and d. D would be the upper limit, c would be the lower limit. We would then get the area between d and e. E would be the upper limit, d would be the lower limit. And we get the area between e and b. B would be the upper limit and E would be the lower limit. So again, remembering the further to the right we go is always the upper limit, and to the left would be the lower limit. And we would then look at each of the areas that we have gotten, making sure that we would take 2 and 4, and we would add it to the absolute value of 3 and the absolute value of 1. And then that would give us the total shaded area. So here in the example, we're given a cubic function, and we're asked to find the area enclosed by the cubic and the x-axis. Now, what we're not given here in the question is the limits. So if we don't know what the limits are, we have to basically find them first. In other words, where the area is being enclosed is between the points where the line cuts the x-axis. So in other words, if I was to mark in my limits, they would look something like that. So we need to basically find these 3 points. So the first thing we're going to do is we're going to let y equal 0 where it cuts the x-axis. So by letting y equal 0, we end up with x cubed minus 4x squared plus 3x equals 0. If I take out x as being common, I'm left with x squared minus 4x plus 3 equals 0. So that means that x must equal 0, or x squared minus 4x plus 3 equals 0. So the factors that multiply to give you 3 and add to give you minus 4 must be minus 3 and minus 1. So we have x squared minus 3x minus x plus 3 equals 0. Taking out the highest common factor between the first two and the second two, we end up with x times x minus 3 minus 1 times x minus 3 equals 0. So again, taking out our highest common factor, x minus 3, leaves us with x minus 3 times x minus 1 equals 0. So again, if both of those multiply to give you 0, that means that x minus 3 must equal 0. In other words, x equals 3. Or x minus 1 equals 0. In other words, x equals 1. So now we have our three limits. We have x equals 0, x equals 3, and x equals 1. So if I go back to my function there and I mark that in, that's 0, then we have 1, and then we have 3. So of course we can see that we have part of the curve above the x-axis, and because it's above the x-axis, I know that's going to be positive. And here we have below the x-axis, so that area is going to be negative. So we're going to get the absolute value of that, and then we're going to combine the two together. Okay, so our function then, I'll actually just go back. So I'm going to call this area 1. And area 2. So area 1 area shaded is area 1 plus the absolute value of area 2. So area 1 is our integral of the function, which is x cubed minus 4x squared plus 3x dx between the limits of 1 and 0. So if I integrate x cubed, I get x to the power of 4 over 4 minus 4x cubed over 3 plus 3x squared over 2. And that's between the limits of 1 and 0. So that gives me 1 over 4 minus 4 over 3 plus 3 over 2, because obviously if I sub in 1 times anything is itself. And then if I sub in 0, well, I have 0 over 4, 0 over 3, 0 over 2, and that will multiply to give me 0. So 4 times 0 cubed over 3 is 0. 3 times 0 squared over 2 is 0. So a quarter minus 4/3 plus 3 over 2 gives me an area of 5 over 12 square units for area 1. So now if I do the same for area 2, well, this time my limits are 3 and 1. And it's the same function, x cubed minus 4x squared plus 3x dx. So I'm just limiting where I'm getting my area for. So of course the answer for the derivative is the same. We've already integrated that. I was about to say differentiated. And we're just changing the limits. So it's 3 and 1 we're subbing in. So that means wherever there's an x, I'm putting 3 this time. And then I'm subtracting. So I'm just subtracting 1 over 4 minus 4 over 3 plus 3 over 2. Okay, so in the first bracket, what do I get? Which is minus 9 over 4 in the first bracket. And in the second bracket, well, we've already worked that out. In the previous part of the question, it was 5 over 12. So minus 9 over 4 minus 5 over 12 gives us minus 8 over 3 square units. So this is why you can see when it's below the x-axis, we end up with a negative area. So therefore, area 2 is equal to minus 8 over 3 square units. So if I get the absolute value of that, that's just 8 over 3 square units. So then by adding those two together, so the total area is going to be 5 over 12 plus 8 over 3, which gives us an area of 37 over 12 square units. So don't forget to write in square units into your answer. So on page 409, you're going to do question 19 and then 20, and then you'll come back to this video for the second example today, which is going to be the area between a line and a curve. So sometimes we can be asked to find the area enclosed between a line and a curve. So that basically means that where the curve and the line intersect, we end up with an area shaded off in blue here, and that's the area that we want to find. So the way in which we have to approach these questions is we look at the two functions as a separate entity, and the area of the shaded region then will be equal to, in this case in particular, would be the area under the line minus the area under the curve. Sometimes it can be the other way around, depends on the function that you were given. So what that basically means that is, if I was looking at that function there, that shaded area is the area under the line between those 2 points of intersection. Well, the area under the line would be that shape there, which is actually a trapezium. So you could use the trapezoidal, or you could use the area of a trapezium, I should say, to get the area of that shape, or you can integrate between those two limit points. And then if we subtract from that the area under the curve between those limits, the area under the curve between those limits would be this bit here and this bit here. So obviously if I subtract that from the trapezium that we have there, we'd then be left with the enclosed shaded blue bit. So we have to make a note not to forget that if we want the points of intersection of the line and the curve, then we simply use simultaneous equations. And that will allow us then to find those points, in other words, the limits. So in this example, we have to find the area enclosed by the curve and the line. So again, we're not given the limits, but we can see obviously that the points of intersection are going to be our limits. So if I was to draw my limits down, I need to work out what these limits are. So in other words, I need to find those points of intersection. So what we're going to do is we're going to take the equation y equals 5x minus x squared, and I'm going to call that equation 1. And we're going to take the line y equals 8 minus x, and I'm going to call that equation 2. And I'm going to equate 1 and 2 because they're both equal to y. In other words, I have 5x minus x squared is equal to 8 minus x. So that gives me x squared minus 5x minus x is minus 6x plus 8 is equal to 0. So we say, well, what multiplies to give us 8 and adds to give us minus 6? So it must be minus 4 and minus 2. So if I sub in, we have x squared minus 4x minus 2x plus 8 equals 0. Group the first two, highest common factor. Now we take out x, leaving us with x minus 4. Take out minus 2 as being common, and we have x minus 4 equals 0. Highest common factor then is x minus 4, which leaves us with x minus 2 equals 0. So that means they both multiply to give us 0, so one has to be 0 or the other or both. So that gives us our limits to be 2 and 4. And we can see that because obviously I'm giving you a scale to x and y axis there. But if we didn't know what the x and y axis scale was, we wouldn't be able to read directly off. So therefore that means that this point here is going to pass through the x-axis at 4 and at 2. So 4 is basically our upper limit and 2 will be our lower limit. Now if we were asked to find the coordinates of these points of intersection, I would then sub back in for 4 into equation 2 there would be easier, and sub x back into 2 as well to find the y coordinates. But we haven't been asked for that in the question. We've just literally been asked to find the area enclosed. So therefore I only need to know the x values because these are my limits. Okay, so to get the shaded area, we can see that the area under the curve this time is actually going to be the bigger area, and the area under the line is going to give us a shape like this, which is of course a trapezium. And again, with your trapezium, this would be your perpendicular height, and these were your two parallel sides, A and B. So you can use the area of the trapezium. However, you would need to know what is A and what is B to do that. And if you want to use that equation, then you would need to know what your y coordinates are. So in other words, let's sub in to find the y coordinates. As I said, we weren't asked for them, but if you're going to use this area of a trapezium, which is A plus B over 2 times the perpendicular height, which is that distance there, then we would need to know the y values. So if I sub x into 2, then that will give me y is equal to 8 minus 4. In other words, y is equal to 4. So that means when x is 4, this height here is 4. And if I sub in 2 into equation 2, I end up with y is equal to 8 minus 2. In other words, y is equal to 6. So that coordinate there would be 2, 6. So that would mean that this height here is 6. Okay, so let's go on to the next page. So the area of the shaded region is going to be equal to the area under the curve this time, minus the area under the line. So again, if I was to sketch that, that shaded bit is equal to the area under the curve between the limits of 4 and 2, would give me all of that bit, minus the area under the line, between that limit would give me this bit here. So by subtracting them, I'll end up with the bit that I'm looking for. So of course we said our limits were 4 and 2, 4 and 2. So we can write that then as the area is equal to area 1 minus area 2. So area 1 is going to be equal to the integral upper limit 4, lower limit 2, and the quadratic there was 5x minus x squared. So the area under the curve you can find by integrating. So if I integrate 5x, I get 5x squared over 2. If I integrate x squared, I get x cubed over 3. And then I'm going to sub in my limits of 4 and 2. So my upper limit goes in first always. So that's going to be 4 squared over 2 minus 4 cubed over 3. And then that's minus 5 times 2 squared over 2 minus 2 cubed over 3. So therefore, if I sub that into my calculator, that ends up with 11 1/3 square units. Or you could write that as 34/3. And then we want to get area 2, which can be found by integrating or by using the trapezium. So let's just say we integrated it. Well, again, we'd still be doing 4 and 2, and the line was 8 minus x. So that would give us 8x minus x squared over 2, upper limit being 4, lower limit being 2. So that would give me 8 times 4 minus 4 squared over 2 minus 8 times 2 minus 2 squared over 2. And therefore that would give me an area of 10 square units. Now, if we did happen to use the trapezium rule, then we would be getting our area is 6 plus 4 over 2 times the perpendicular height. So if you look, 6 was A, 4 is B, the parallel sides, and then the perpendicular height is this distance here. So therefore that must be 4 minus 2, which is 2. And therefore you can see that's actually really much easier, because again 2 goes into 2 once and we're left with just simply 10. So if you can see the regular shape there, like sometimes the line will cut the x-axis making a triangle, sometimes it makes a trapezium. So it's just about spotting it. So now we have area 1 and we have area 2. So therefore we say the total shaded area is 1 minus 2 there. So it's 34/3, and I'm subtracting 10 from that. And therefore that gives me the area to be 4/3 square units. Okay, so what you're going to do is you're going to go to page 411 and you're going to do question 2 and you're going to do question 3. And that's it for today.